Okay, so let's start by revising or reviewing the terminology from first year. With respect to lines and angles, so the line AB passes through the points AB, and this is how it's noted in geometry. The line segment AB with the square brackets starts at A and ends at B. The ray with one square bracket AB starts at A, that's the square brackets on this side, and continues through B. So that you'll notice there's no square bracket beside B. The points that lie on the same line, they're collinear, so A, B and C are collinear points. And lines L and M intersect is the word there at the point P. And also parallel lines, L and M, are lines that never meet. They're known as parallel lines, and the lines L and M that are at 90 degrees to each other are known to be perpendicular to each other. Okay, if we look at angles, we just remind ourselves that terminology-wise, this angle in here, AOB, is given by the angle AOB if we're referring to it. And this notation refers to the angle in here, which is the center letter. But if we're talking about the size of the angle, then we have to include our straight lines in between. Okay, so that means the size of the angle AOB, and that just refers to the angle AOB. We can consider a right angle, 90 degrees, or straight angle, which is 180 degrees. We can have an angle that's less than 90 degrees, that's acute, an angle that's between 90 and 180, so it's somewhere between, somewhere in here, that's obtuse, and we can have an angle that's known as a reflex angle, that's somewhere between 180 and 360. So this angle cuts around past 90, past 180, and it's somewhere in between. It's somewhere between there. It can be anywhere really up to 360 degrees. And it's known as a reflex angle. And when we have an angle here that's between 90 and 180, we refer to that often as the ordinary angle. And if you recall then, when we have two lines intersecting, they generate four angles. Okay, these two and these two. And the angles that are vertically opposite are equal in measure. So A is equal to A and B is equal to B. And then the angles at a point P add up to 360. So all of these angles, 1, 2, 3, 4, 5 angles, make 360 degrees. Okay, and then we'll talk about angles and parallel lines. So if we have two parallel lines, and we have a line that cuts through both lines, known as a transversal T, then the angles generated, there's four angles generated up there, if you like, and four more here. The corresponding angles are equal. Okay, so that's equal to that, and the lower one's equal to that one. And if we consider two parallel lines and a transversal slicing through, then the alternate angles are equal. Now sometimes when we look for corresponding angles, we look for the F. It's an F there, okay, and sometimes we look for the, look for the Z. So we might say there's a Z there. Let's cover that in a bit more. But these are the alternate angles and they're equal. And then sometimes we might look for the C to capture the interior angles, which add up to this angle plus this angle adds up to 180 degrees. So a couple of examples using those rules. So we're given this two parallel lines and a transversal cutting through them. We're told that A is 48 degrees. Find, this angle is 48 degrees. Find A, B, C, D. So A is vertically opposite to 48, so it's 48 degrees as well. B is part of the straight line angle associated with the 48 degrees. That must be to 180 minus 48. B then is equal to D because they're corresponding in these parallel lines. That corresponds to this. And then D is equal to C. It's vertically opposite. Okay, so there you go. There's all those angles sorted there. And we might have one where we have an expression that 4n plus 60 degrees, that's that angle, and this angle is 120, find n. So this angle, this is a parallel line, it's a transversal, so this angle corresponds with this, so that means that their measure 4n plus 60 must be equal to 120, n is equal to 15. And if you were to check, plug n is equal to 15 back in, you'll get 120, which tells us that this is 120, and it is 120 because it should be, because it corresponds with this angle here. Let's talk about angles and triangles. So here we have a triangle, three angles within the triangle ABC. They'll always sum to 180 degrees. We have a triangle here, and it has an exterior angle C. The exterior angle C is always equal to the sum of the interior opposite angles A plus B. The interior opposite angles, that's what C is equal to. We have an equilateral triangle here. Just to remember that they have three equal sides and three equal angles, and that angle is 60 degrees. An isosceles triangle has two equal sides, and the angles opposite the equal side are equal to each other. So here's an example using those rules. If we're given this quadrilateral here, okay, four-sided figure, and it has a diagonal cutting through from P to N. We're asked to find the angle MNP. So that's this angle here, that's MNP, MNP. And then we're asked to find the angle PMN. Okay, PMN, that's the angle PMN. So first of all, let's look for MNP. Well, MNP is fairly straightforward in that it's equal to 29 degrees, because if you think about it, you have two parallel lines, you have a transversal, and you have alternate angles here. You know this is 29, that must be 29 as well. There is the Z. Okay, and if this side here is equal to that side there, that's given to us at the beginning, then this is an isosceles triangle, and the sides opposite the the angles opposite the equal sides are also equal. So this angle is opposite this side is equal to this angle opposite the other equal side, so that must be 29 degrees as well. So then we're asked to find this final angle here. Well, if that's 29 in here, and this is 29, and the sum of the angles in a triangle is 180, then this angle in here must be 122. We have a triangle that's 29, 29, 1, 2, 2. Those are the three angles, all adding to 180. Now, this is the discussion on question 9, page 156. Given this diagram here, how can we show that the angle A plus B is equal to D? Now, D is all of this angle. It looks a bit confusing in the book, to be honest, but D is all of the angle. It's X and Y. Okay. So, the first thing, I suppose, is to show that X, this angle here, caught between those two parallel lines, that transversal, is alternate and equal to B. Okay, so there is my Z, that's equal to that. So B is equal to X, or X is equal to B. And then we can also show, if we come along this way, okay, if we look at this sorry, I'll do it here actually, with two parallel lines that shoot through here, and we have this transversal now going this way, we work with this transversal, then y is corresponding to a. If you think about it and look at it, they're corresponding, so y is equal to a. So d, all of d is equal to x plus y, and x is equal to a, and y is equal to, sorry, x is equal to b and y is equal to a. Therefore d is equal to a plus b, which proves that.